Today we will talk about section 13.8 and the extreme value theorems. Just like in a single variable function, we are now interested in order for our purpose of understanding of extremity, how derivatives of a several variable function, critical points, and extreme values are related. Before we start talking about relative extrema, we will remind ourselves what do we mean by global extrema. So that brings us to the extreme value theorem, which basically says if you have a continuous function of two variables, x and y, defined on a closed bounded region R on the xy plane, then there is at least one point where it takes the maximum value, and there is at least one point where it takes the minimum value. So what we need our function to be a continuous function of two variables, and we need the region to be a bounded closed region. Then we know that there is a point, at least one point in this region R, where the function takes the minimum value of all other points, and there is at least one point in this region where the function takes the maximum value. So this minimum is called the global minimum, and the maximum value is called the global maximum value. Now, global maximum and global minimum are not necessarily the same thing as relative maximum or relative minimum. There could be functions where there is no global maximum, global minimum, but multiple relative maximums and relative minimums. So what are relative maximum, relative minimum? As long as I know a function is defined on a region R containing a point x0, y0, we say the point x0, y0 is the point of relative minimum if we know for any other point x, y in this region R, the value of the function at the point x, y is greater than or equal to the value of the function at the point x0, y0. So I get to say for all x, y as point in this region where the function is well defined, your functional value is greater than or equal to this particular functional value at this particular point x0, y0. Then I say if attains a relative minimum at the point x0, y0. Whereas on the other hand, if I say for all xy points in this domain of R, in this region R, if the value of the function at x, y is less than or equal to the particular value of the function at the point x0, y0, then x0, y0 is a point of relative maximum for the function f. Or in other words, if attains the relative maximum at this point x0, y0. And remember, these are only over the region R. It doesn't have to be over the entire domain of definition of the function. Hence, we cannot call it the global maximum or global minimum. They are locally maximums and minimums. So relative maximum or relative minimum. How they are related with critical points. So let's first define critical points. We're going to say a function f, which is defined over an open region R containing a point x0, y0. So you have an open region, and for no particular reason, I'm going to take an open circular disk. This is the open region R in my Cartesian coordinate plane, and there is a point x0, y0 in this region, say. And I'm going to say if either both the first order partial derivative fx at this point x0, y0 is equal to 0, as well as if I do the first order partial derivative with respect to y and evaluate that at this point x0, y0, then the point x0, y0 is a critical point for my function. Or if at least one of the first order partial derivatives, so the second condition says that either fx at x0, y0 does not exist, or if y at the point x0, y0 does not exist. If one of these two happens, then I get to say that the point x0, y0 is a critical point for my function. So the first condition says that both partials has to be 0 in order for the point x naught comma y naught to be a critical point. But the second condition says as long as one of fx or fy does not exist at the point x naught comma y naught, my function will have a critical point at the point x naught comma y naught. Finally, it relates all of it. So the relative extremum x naught comma y naught on an open region R containing the point x naught comma y naught is going to be a critical point for the function f. So what does it say? It says that as long as you are a relative extremum, you must be a critical point. So relative extremum, if you know that a point is a relative extremum, then I must get to say that the point is a critical point, but not the other way around. For example, there are a bunch of critical points which are not going to be a relative extremum. So just because I get to say that I'm a relative critical point, I don't get to say that definitely I'm going to be a relative extremum. And this is very important for us to understand. Even with this result, I get to say, so when I'm finding the relative extremum, I will narrow my choices of points where I can get the relative extremum to the points of critical nature. So you find the critical points, then we will learn some other techniques in order to understand which one of those critical points are relative extremum. But as I said, there are critical points which are not relative extremum. In several variable function, we will name some of these points as the points of saddle or saddle points. And I'm going to talk about saddle points in the next portion of this video.